The old man built. The old man built. The old man built. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man.
Hello everyone, my name is Nathan, otherwise known as Old Man Bills. Welcome, we have Shawn Calderon here. Shawn, how you doing?
Good. Glad to be here with you. Thank you.
Yeah, it's an awesome day, man. Did you get some cool stuff going on with some geodes today? I'm so jacked to see that.
Yes, I can't wait to share my results. There's some things that were unexpected, so I think that'll make it extra interesting.
Oh, geez, right on. All right, Shawn, I'm going to pull up your stuff here.
Awesome, and I'll set it up.
You're good to go.
Awesome, sir. Hey guys, it's great to see you on the chat. Guys, you are the reason why we do this. We love your comments and being just part of this group. And really, we couldn't be here without you guys. So I sent my dad some black paper to my dad and for his birthday. So he drew me some eyes, and this is one of them. He really likes Sharpies, so he drew this for me in Sharpies, and he's very talented. I love his impressionist art, so I thought I'd just give my dad a plug for what he's doing. Um, so we're talking about now, just again, interaction between plasma and different objects. You guys have seen this now 3 times, but I just can't delete it from my presentation file yet. It's just too cool because it has that concept of the Tesla coil being a pump, how there's this push-pull energy from the earth, because this is an earth ground there wire up at the top. And we see streamers coming from the bottom and the top, and then we have the lightning strike. So I just love this. It's just so cool. And I keep forgetting to look up why there's a yellow hue when it finally connects. That sort of, and I'm not sure if you guys can see it from your end, but I can see it pretty clear. All right, so we're going to be a little bit all over the place as usual. Now, if you want to start reading your input to your ZVS from your Variac, you can place the oscilloscope across the diodes. Now, I did mention this last week, but I didn't have this really good slide next to it, and that's this. So what the diode does is, first of all, you should have a complete sine wave. Should go up, and then it should go down below the 0 line, below the green line. You should see that S wave. But what this diode is doing is it's cutting off the bottom part of the sine wave. And so what's happening is that these positive pulses are hammering at the oscilloscope, and I'm sorry, not the oscilloscope, the ZVS. And what the ZVS is doing is it has this sort of ramping up to a peak and then letting go, ramping it up and a peak, letting it go. And this is connected to those tendrils, those twisting plasma that comes out of it. Those spinning plasma streamers, I guess that we can call them, are due to this waveform shape right here. This pushes out and then fires off the purple that we're all familiar with. So I'm setting up my high voltage lab for electrets, and I picked up this really nice Wimshurst on Amazon, and this Russian-made Van de Graaff here on the left. Oh boy, worth its weight in gold. Super cheap on eBay, and I thought I was going to need a 212 connector for it, but that's not the case. And so, yeah, a lot of energy coming from it. I'm going to be using it here in some experiments. All right, so I finally decided to wind the silver wire. Now, I wanted a twin for the silver wire. So here I am winding. I'm going to do the twin in white, and then I'm going to wind the silver wire in blue. And I kind of just wanted to show you what I'm doing, how I'm winding it. And here's a side view. And now it's like a drill bit, so you just take it out. This is really convenient. Now, in taking apart old junky printers from the thrift store, you get these really nice stainless steel rods, and I use them everywhere. And they're shiny, they're really heavy, and so I usually will put my coil on one of these printer rods. But I'm just kind of showing you how I'm winding. I'm done winding, and of course I have my signature record table here for my coil to turn. And this is the part of the pursuit. I don't want to call it a hobby. The pursuit that I really enjoy is winding coils. Just love it. They're works of art, I feel like sometimes. Now here I take my measurements of the coil. It's 410.4 ohms. Now if I hit the auto button, it'll start to look, auto seek it. Now it's giving me ohms again, but now look at the left corner here. It says LS. And now it's reading Henrys. So Henrys at 120 hertz. I'm going to hit the frequency button. It's 1 kilohertz. Hit the frequency button. It's 10 kilohertz. And then hit the frequency button for 100 kilohertz. Now at 100 kilohertz, the inductance, the Henrys is off the charts. It's greater than 2,000 Henrys. I kind of doubt that, but it's super off the scale. And that's one of the reasons why these coils that are densely wound, they have so much power. You'll see my little tiny coil will just push out these massive plasma discharges. It's because it has at 100 kilohertz this massive absorption and what's the word? Absorption and then pushing out, be a good way to put it, of energy. And so I thought I would just share what I do. And I write these all down, and then I compare them, and it's just part of the stats I like to collect. Now here's the blue coil that I'm going to be winding with pure silver. I should say the 99.9% silver wire. It's silver magnet wire, so it has the same characteristics of the copper magnet wire. So one of the things, I just drilled it, and now I have a different sized rod here from one of the old printers I took apart. And I'm going to do the same thing. I'm going to put it on my winder. And one of the things too is I'll use thicker wire from my old wire bin to hold it together. And here I'm just showing you how it's going to be spinning as I wind the coil. There's the bundle of silver. I thought it was bigger, but it's 5 pounds. And it's an obnoxious gauge of wire, which I didn't. So I got 50% off this wire, and this wire is not cheap. It is very expensive. I got 50% off the wire because it's a odd gauge. It is a 33.5 gauge. So it's not 34, so I can wind another 34 gauge wire coil with it. It's not 33, it's 33.5. So I did my calculations wrong on the white coil, and so I'm going to wind this. Oops, let me go back here for a second. So I'm going to wind this silver coil, and then I'm going to have to print another white one to match, because I want the same mass. I want the same volume, or not volume, but mass. I want these to weigh the exact same. That way, when I do the experiments, I want to compare silver to copper. Now, a little bit out of order, but I created this little copper pipe here, and I cut it so that way it can sort of come out like a flower, is what it looks like. And I'm going to start putting stones on it. And this is my amber coil. And I'm going to push plasma now through some stones that I have laying around my lab. So this one's quartz, and it's interesting to me that it'll work along the contours of the quartz here. So if it could go straight out, and it should go straight out, but there's something about the quartz that draws it to it, but it doesn't have an interaction. There's no getting heated like normal plasma would heat this up. So it's sort of training the direction. Now, see all those tendrils, all those coming out? That's from those humps, those positive humps that I showed you earlier. Now, again, I'm cranking the voltage here. Look at that. I'm cranking it. And again, it's not interacting with the quartz as basically burning or charring or doing something like that, but it is sort of hugging it, if you will, or wrapping its tendrils around it. I think, let's see. Yeah, I think it's just another video of it. I thought it was pretty cool looking. If you were to show somebody this on the street, they'd be like, "What is that?" Something from at the Infinity Stone. There you go, from Marvel. Oh, there you go. So I wanted to show you how much energy was under this piece of quartz, and yeah, this is my amber coil. Amber, this is my last day with amber. I'm shipping it out to a friend of mine, so I'm going to be winding another sphere in the future, but amber's going to get a new home. And yeah, look at all that power. This is about 25 volts input, and about 8 to 10 amps. So I'm kind of showing you how I did it, and the shape of the copper on top. So now I'm going to start putting rocks in the middle of this little spot here. Now, this here, I'm taking this is a slice of a geode, and it's doing that sort of signature running along. It's kind of sucked to the sides to be very flush with the rock, but it's not interacting with the rock. It's just sort of kind of hugging the rock. It's probably a better way to say it. Oh, let's see here. Now, this is the geode that was causing these little explosions. I mean, and when you look into it very deep, it's really cracking through that black exterior right into the crystals. And it's almost like it's conductive. Can you see sort of how the electricity just running through the rock and it turns that really bright orange? So what I decided to do is get some really good video of it to share it with you guys. Yeah, sorry about the shaky video. And I Googled it, and it's supposed to be this stone here. I wrote it down. It's called chalcedony, and I know I'm saying it wrong. And so I thought, okay, well, I have another piece of quartz with chalcedony. I'll try it out. But I also found out my research that geodes can be covered with lava. And so this has a black output. Now look at it, it's ignoring the crystals inside, but it's sort of grabbing hold of the black like little fingers, little orange fingers, and it's really trying to get into that geode, or at least run along its surface. And it's definitely having some kind of almost an explosive reaction. Now, I thought, since this is not chalcedony, because I tested on chalcedony, I thought maybe it's lava. So I ordered some lava, and we'll show you what lava does here. So kind of a picture of the setup here, so you can see it in the light. Let's see, a little bit more light. You can kind of see, has the black exterior, and it has that sort of flower shape. It's actually more than 4 petals. Kind of showing you the setup, kind of give an idea of what it looks like. There's Uber 2, the ZVS circuit back there, and this is the setup basically. So I'm really getting interested in how the streamers break off on this top that I put on, this sort of flower shape. Now I'm going to be doing, yeah, here we go. So I put it a little bit more distance, and what you're seeing here is it's still hitting that. This is the backside of that geode. Now, every other stone, it doesn't do this. And of course, I don't have a huge selection, but we'll be going through some. But there's just something about that interaction here that it seems to go from the outside in with a really deep heat, a little bit of vaporizing, I think, of the surface materials from the hot plasma. Let's see here, there. So I moved it closer. Now you can see that it's ignoring the crystals inside the geode, and it's just jumping out to the side, sort of dancing. And you can see that really hot spot. That's probably where the black rock around it is cut. You can see now that the electricity runs really through this rock. It's almost conductive. And I just thought, wow, that's so incredible. Because it's not just having these little explosions, but it's actually running through the top here. And this is a very thin layer. And this is not a treated geode. This is just dug out of the ground, wipe off the dirt, and I bought it. So this is the natural coating that it came with it. So I'm doing some more experiments, just trying to see different directions on there. Now you can kind of see how it has these long fingers, these long orange fingers. And you can see in between these orange fingers that it lights up inside, and it almost like you're getting a view into the crystals because it has that sort of purplish hue. And there it is. Now it's got some spot there. Now another thing that's cool is if you look at the bottom here, the geode is actually absorbing the energy and passing it right back to the sphere. So let's see that again, because that's pretty interesting. Let's see here. Oh, here we go. There we go. So look at the bottom here. It's just going, the stone is just sending it back. And I've not seen any stone do this. I've not seen a stone fill up with energy and just throw it right back into the coil. So there's something fascinating about this coating. Okay, I'm going to do another piece of quartz. Let's see here. Okay, bringing it close to the plasma here. Now it looks like it's interacting with the quartz, but it's not. The clamp that I'm holding on, that's really causing the tendrils to go up. And you can kind of see it because the clamp has like a rubber coating on it, and it sort of hits the... So now it runs on the outside of the crystal, though, which is very fascinating. It won't go around it. It sort of runs alongside of it, almost like it slipping on the snow or something, because it's very slick electrically, maybe, possibly. But then it's ending on this clamp that goes to a metal surface. So another cool thing is that if this quartz was really interactive, these tendrils would be all bent toward it. So it's not doing that. But that's what quartz kind of looks like when you're putting probably 500,000 volts. I don't know. At least we'll just say it's 100,000 volts. This little coil here can do 12 to 18 inches probably if I really maxed it out. And I think 12 inches is a million volts. All right, so I'm trying another slice of a geode that I have. It looks completely different. You can kind of see again, not really interacting. I mean, it's sort of slipping and sliding to the clamp that's holding it, but it's not. It kind of doesn't know it's there. And so not much interaction. Kind of see it on the light here. So you can kind of see the clamp, and it's holding this polished slice of a geode. Now this is magnetite. I'm putting now little rocks on top of it to kind of see what it's doing. You know how much power of plasma is under that rock. So I'm hoping to kind of see, well, what are these different rocks are going to do. And the magnetite, I don't know. I mean, I think it's spreading out the arcs, but it's kind of not really interacting much. Everything is sort of being pushed out from under it. So I'm kind of saying that this is probably no interaction or very little interaction. All right, I'm gonna do periodot. These are just things I got from gift shops, going to museums and stuff. I'm just kind of going through periodot. And I'm putting in a little flower top there, and then we're going to see turn on some plasma. You can see all the little rocks I'm going to be testing. And I don't know what peridot is. It just looked cool to me when I bought it. So I'm turning up the voltage, and I'm waiting for something, kind of to see something that's out of the ordinary. And not really. I mean, the plasma looks a little different because I'm turning it up. So it seems to be maybe a little bit more dispersed and maybe a little stringy. But I was hoping for something like the outside of that geode. Maybe we get some different colors or something. But no, not really. Let's see here. Is this periodot again? I might show it here at the end, but this coil wants to go. It just throws out so much energy. It's so tuned. So super easy to work with. I wish I knew it was in there, but obviously it's not working, interacting. I think I might show it at the end here. Let's see here. But it's quite the display. It might be even changing the color slightly, maybe a little pinker, but it's hard to tell. And no, it didn't show us what. All right, we got blue topaz. Put it in a little spot here on the top. I'm just going through the motions here. Actually, I already pre-fill it. I'm just trying to sort of show you guys what I'm doing. All right, so this is blue topaz. I don't know, the hue might be a little different. It's definitely not really directly interacting with it, but maybe indirectly it has a little bit more blue haze. Not sure. I mean, again, I'm sort of hoping for something similar to the geode, or just, I don't know. It's still pretty. It's still cool. It's just sort of looking like the same old, same old. And I don't even know what blue topaz is. I think Joe's our resident geologist. That's pretty cool. There is a fluffiness around this topaz that that does look distinct, because you don't get that sort of fluffy appearance unless you have more of a smooth DC. So maybe that is onto something there. See here, there we go. Let's see. There we go. So there's a kind of fuzz of a sort of fluffy haze. I'm going to stop it here because I want to show you something. Let's see. There we go. So when you look at it here, this is what DC looks like. This is not AC. This is DC. And when it's fluffing, it's hard to see here. Maybe I can see if I can use my arrow key here. Yeah, there we go. So if you were to take any one of these strands individually, like this is a perfect example. These are DC bursts. So there's something about maybe the blue topaz that's changing that lightning bolt kind of looking and changing it to a smooth DC, because these definitely look like smooth DC output. So something about topaz that's pretty interesting. I look forward to your comments and questions, guys. Doing some interesting stuff. I'm kind of clearing off my list. Here's citrine. Clearing off my list so I can do more electret stuff. So I'm having fun with plasma. All right. Let's see. Citrine. It had a little bit of that DC action too. So that's interesting. Not seeing a whole bunch though. Still sort of seems the same. Yeah. Trying to look at it at different angles. Yep, different angles. See if I can fix it here. No, I can't. Sorry, guys. This is creativity. This is right here. Having fun. Let's see. So I started playing with these balls. This is xenon, these spheres. I was complaining because it should be one color and has this green color, which I believe is oxygen. Might be nitrogen, I'm not sure. But what I'm noticing is that the plasma output, and this I'm putting in 6 volts into the amber coil, and I'm getting quite a bit of power. I'm becoming a capacitor here. So as I bring it closer, you'll start to see streamers from my fingers, and I can feel the electricity on my body, across my body, but it's not harming or anything. It's more like a static electricity. And so this pretty much looked like a plasma ball that you buy. Now this really interested me because this is krypton, and this shape, it looks like a diagram for atoms, not atoms, electrons. So a lot of people think that protons, neutrons, and electrons are sort of like, you got the protons in the middle and the electrons orbit, but it's not really the case. That's just taught so you can wrap your head sort of around how atoms work. But really it's this probability cloud. And the way the plasma was changing this, it's a looks like a probability cloud of electrons. And I think I found a photo of that later, but I wanted to point that out, that this krypton's working a bit differently, and it doesn't have any green in it, which is good. Actually does have a little bit. And again, I'm a capacitor. It's charging me, and then I'm charging this sphere, and it's pretty cool stuff. Now it's striking it, and it just looks like glass being struck. Yeah, see, again, this looks like probability clouds for electrons. All right, we're gonna do a little helium. I want to get a whole set of these, but they're outrageously expensive, and I just hate to buy one little ball here for 40 bucks, 50 bucks. It's just, yeah, it's so expensive. So, all right, we got helium. Has a little bit of that shape too, almost like a probability cloud. And so I thought that was interesting. And it definitely has a different hue because it's a different gas. And it's sort of creating two, sort of almost like a ring around it. And when I touch it, it actually changes colors. I thought that was interesting. I thought it would just stay. So for the other gases, it would stay the same color. But this one here, it's mixing an orange from my fingers to, it was a blue, a pale blue, and there it is again. And this was interesting. Why am I getting the two colors with helium? And I know you guys in the chat could answer all these questions. I can't wait to hear what your comments are. I think I have one more. Let's see here. I forget what this one is. Maybe xenon. That's right, xenon. Again, I'm getting charged by the field. Look at that, it's touching, sort of zapping it. So I'm really close, and I'm feeling it on my hand, but it's not painful. And so we're seeing the green tendrils inside of xenon. I have to figure out what this green is. Maybe Gerald can inform us in the chat. So I'm just letting it strike it. And oops, see, it zapped me, so I pulled away. And so that's xenon. All right, yeah, these are out of order. I'm winding the silver coil here, and I'm so nervous around this coil that I'm hand counting every turn of wire, 5,000 turns. So on the right of me, I have YouTube on, and this took quite a bit of YouTube and a lot of turning and twisting. Here we go. We got both coils, only for me to discover that I got my calculations wrong, and this coil doesn't match the silver one. So this will still be a great coil, but yeah, no, this is what it should look like more. So I need the same density. I want to work off at least the same mass. And of course the copper is going to be a little bigger because I think silver is more dense. So then I'll be putting it on a rotisserie and putting some epoxy on it. Okay, here again we have the back of that Geode. Boy, I got a lot of shots of this. I think we've seen enough of this. All right, a close up of the Geode. And maybe this is a different kind of Geode. It seems like all the crystals are small and they almost seem porous. I think we've seen this again. I just kind of wanted to see how it worked. Yeah, it's just going out. It's not going in. And it's just running on the exterior of that black rock that's coating the Geode. All right, more quartz. Okay, so in my study, see that brown stuff at the bottom of the quartz? That's supposed to be a type of chalcedony. I'm saying it wrong. Let's see here. I want to see the chalcedony. I think it'll come up. So right here, this is called a diamond, and it's not really a diamond. There's a volcano in Northern California, and there's a lake in the middle of the giant crater. And on one of the mountain slopes is this sort of muddy clay. And if you're there on a rainy day, as water begins to run down the mountain, these diamonds are called Clear Lake diamonds. They show up, and this is a rather large one. So what is this? Well, I did my research, and it's definitely not a diamond, but what it is it's a quartz that has been heated, then cold, and then remelt. So it's melted twice. It's melted, then it forms a crystal. It's melted, and then the quartz becomes this really super clear stone. So I thought that would be interesting. Again, it's part of my rock collection, and there's a little legend behind these. These are supposed to be the tears of the Pomo Indian princess, and the chief Kanaktai was weeping over her death. She died, and these are his tears. And so when you go down the mountain when it rains, which are his tears, you can see these peer up. And I have a whole box of these. So, and it's fun to go diamond hunting. If you get a large one, this is not largest, this is just big, but not large, if that makes sense. But if you get one about 5 times this size, yeah, it could be worth something. So it's kind of one of those work really hard, you might get something worth something. So I'm just throwing things in the middle of amber because amber is packed up. Amber's going home to its new home. And so this is an antenna that I had laying around, and I thought it was interesting. All right, so this is my failed attempt at winding a pancake coil. It was going so well. That circular piece of acrylic came from an LCD monitor from the thrift store. It's pretty thick, but I'm going to show you here that I had wound it all the way to the edges, and then see this wire here? It just literally springed off and like jumped at me, and I was so heartbroken. So so this was a fail, and because I just don't have enough turns of wire, and this is the coil 1 that I made for it, and I'm using the capacitor bank that Ian gave me. Oh, this is the best thing ever. I use it all the time. It's really nice for tuning in capacitance for these kinds of experiments. Okay. So I'm starting to do readings, high voltage readings. So this is a 500 million ohms. And I wound the resistors in this helical form, and then I put it in epoxy. And so this allows me to read up to 30,000 volts without harming my stuff. This is so I'm going to electret. So I'm going to be switching and do more of electrets. So this is a power supply that I bought. that boasts 60,000 volts. So I'm testing it. Right now it's about 35,000 volts. And my meter, my probe that you saw, I can't go past 30,000 volts. So it's in that reference frame, or in that frame, rough area, I should say. You can see the on the right here. It's a rather large power supply box. This is what's used for ionizing paint spray or ionizing powder spray, and it charges every paint molecule, and so that way then it goes perfectly thin, and you don't waste paint. So I thought, well, maybe I can get a good field out of it, electric field. So I'm just checking it out. I thought this was way more serious. When I pulled it out of the box, I thought, oh dear, I have to set up a whole workbench. I'm gonna have to wear an asbestos, space suit, and then I turned it on and I went, oh, this is it? What? Um, but it's more about creating large fields than it is about jumping arcs. So I got to give it, I guess, the benefit of the doubt on this one. So I'm going to be running this kind of field to charge materials, insulators, and hopefully they'll stay charged, and that'll be an electret. So I'm playing around with let's see here. So yeah, I'm using my Variac to power this monstrous power supply. Look at how big it is. I mean, it's huge. It's not heavy though. It has a lot of fans, and you turn this dial here, and it goes from 5,000 volts to 60,000 volts. So it's the real deal. It's got this super high voltage protection, that rubber coating on the outside. So even though this doesn't look exciting, it could be mean. It could hurt you. So I'm just kind of testing. It boasts of 30 centimeters, and but I don't think I'm doing something right. So that arc should be way bigger. So here's the probe I set up to measure it, and so my meter only goes up to 600 volts. So I'm using the probe. If you do the math, see, as soon as it hits 650, boom, it goes overload. This is not good for my meter. I have to keep it at 600. So what I have to do is take this reading and times it by 50. And so this was roughly 35,000 volts. And so the probe really saves your meter. And again, it only costs maybe 15 bucks in resistors. Here it is again. And if you guys are interested, I can reference you the resistors that I bought. Let's see. I'm doing that same thing where I zoom in on the O-scope, but I have no idea why. Until I guess it gets to the second part. Oh boy, that was helpful. All right. So I'm measuring with the meter with these giant arcs, and notice the arcs change. I have no idea why the arcs are changing, but it looks more like DC. It's that white color. It's real thick and jaggedy. And this is the waveform. And yeah, it doesn't look like DC to me. It's like a mix, because my meter was measuring DC, so there's DC in there somewhere. All right, so I'm measuring the potential on these leads that I'm seeing if they have these super high dense fields, and I mean, it's hard to get it right, so it jumps all over the place. Nothing exciting, guys. You can see here now that I'm jumping the gap with the plasma, and it jolts up, but it's hard to see it, to about 10, 12 kilovolts. Then it goes back to this piddly number. All right, so Coney, he's always liked Amber, so they're going to be together. And I got my Uber 2. I've got the 2 concave primaries, and these are going to be shipped tomorrow to a good friend, Charlie C. He has a channel, so I recommend you look him up. All right, so electrets. Now, in my study, polyethylene is really good at holding a charge. You melt it, then you electrocute it, and then it cools, and then you can get an electret. That's the thinking here. Now, you guys can go on Amazon and buy a little piece of, like looks like a little board of rectangular shaped polyethylene, and you'll pay 20, 30 bucks, 40 bucks. It's ridiculous. So I found this little bag of, well, it's a 10-pound bag for bean bags and dolls and crafts, and awesome, look, it's polyethylene. So this is sort of how I'm cheating and getting a lot for a low price. And these are the beads inside, and there's a little polyethylene beads. Now, what's cool about these is not only am I going to melt them and try to create electrets, but I'm also going to put them in the bingo twirler and see if I can create massive electrostatic fields with them. And so here, I'm just going to see how it melts. This is just kind of an experiment. How are these guys going to melt? So you're going to I'm going to put it over here in my messy kitchen, my messy stove, and we're going to heat it up. And this is what it looked like. It turns perfectly clear when it's melted. And I don't know why I'm showing my stove again. And so I'm going to put it over here. And what I was doing here is to see how long it held the heat. And I'll tell you, 230 degrees is its melting point, but it's such a good insulator. It's such a good dielectric that it takes about 15 to 20 minutes to get to room temperature, because it just literally doesn't want to push heat to the next guy. It just wants to hold it. And so this is going to be amazing for electrets. And so I timed these with the infrared, and I tested them, and now I'm just again creating electric fields. This time I'm using the Van de Graaff generator, and so this gives me an idea of what kind of fields I can create from it. And I was moving these plates closer and further and just making readings and kind of testing it. Now here I tape a green ground wire to the top, and I'm trying to show you there's the rubber band. See that rubber band? That's where all the electrons come from. That's amazing to me, because you're getting 10, 15, 20,000 volts off this thing. Now you can see that I'm just simply rolling it. And what you're going to see here around the corner is you're going to see this. And this looks like a comb, and it does not touch the rubber. It actually has about a 1/4 inch distance, but what it does, it scrapes off the charge off of the rubber band. That is just fascinating. You would think it had to scrape the material, because to rub two insulators to get a static charge, but not here. You just have this comb 1/4 inch away from the rubber band, and then the rubber band goes really fast, and then it scrapes the charge and throws those little white lightning bolts. So super fascinating. Now here I have the bags of the oh boy, the polyethylene. It's also referred to as PE. So here we have the P balls, and this is funny. I put it on mica, because mica is very heat resistant. And now I'm building my DC intense DC field, and I'm going to just call it the pizza oven. Okay, so I need to melt the cheese here for the pizza oven, and once it's melted, then I'm going to put it in the middle. And here, look at it. You got my pizza oven. I put copper on each side. And so you remember you saw those sparks from the Van de Graaff generator? Well, now I'm going to use this to create fields. And hopefully the field's strong enough to charge the polyethylene, and we'll have an electret. Now, I have no idea what I'm doing still, but I feel like this is getting me closer. Now, one of the hilarious things is here, I'm just kind of showing you, I'm not really doing it. But when I actually did it with a heat gun, it blew all the beads off the table. And I thought to myself, what a goof. So here I set it up. We're going to have my pizza oven, and I got to melt the cheese pizza. So, but yeah, I blew all the beads, and I go, okay, I have to do something better. And so I used hot glue, That way the beads couldn't get blown off. I don't know why I'm showing this so much. So, oh yeah, so I'm showing you that you see that. So it's still creating these little lightning bolts, but if I space it out like this, and I'm using these old 3D prints that I useless. I never throw away my old 3D print jobs. I just repurpose them. Right. So here we go. Now we're getting about a 7,000 volt negative on the bottom because there is a polarity. And then we're going to get about, I want to say 10,000 on the top one. But we should see using the electrostatic meter. There we go. Oh, it's about, oh, there you go. Yeah, it's about 10,000. Now the bottom is 10,000 too. It's just, it was a poor spot to read it. So we're getting a 10 plus 1,000 volt field, electric field, that I'm going to put in the melted polyethylene. Hopefully that field will alter its molecules and we'll get an electric. So you see now I used the glue gun to keep them in. So that was a mistake. And so I was able to melt it. R2D2 is sucking in the fumes, and there it is. It's in the pizza oven. Now, I'm going to use the, oh boy, the imaging camera to monitor it. So it's 248 degrees, a little bit over its melting temperature, which I think is 232. And I'm just going to wait. And this one took about 15 minutes as well. Here, now it's down to 200. And my messy shelves, I'm going to grab the electrostatic meter and let's see here, do some readings, make sure we're doing what we need to do. I forget why I'm doing this. I think I'm getting ready to, oh, I'm just taking other readings. Okay, sorry, this is a little too much. Oh, the best tool ever for cutting PVC pipe. This cost about $8 at Home Depot, and I cut all my PVC pipe up to 1.5 inches. So I thought I'd throw that out, these little tips. I know they helped me when I was learning. So yeah, this is a little cool knife. All right, so it's getting cooler. It's 92 degrees. And there's the setup. Now the top, you can see that it was melted and now it's cooled. And so the top one was charged, but this bottom one, I'm going to melt and not put it in the pizza oven. And that way I have a control, and then I can compare these to see if I actually charged the one that was in the field, if there's any electricity in it. So now I have real heat coming, and I'm trying not to burn it. This is about the dumbest way to heat this, but I had to learn. I'm going to be in the future melting these more evenly in the microwave. I picked up a microwave from the thrift store and it works. So I'm going to really melt these more evenly because I burnt one, and it's really hard not to burn them. Now here I'm zeroing out the electrostatic meter on this aluminum square. It's actually a thick aluminum square, and you can buy this for $8 at Home Depot, and it's for mudding. It's for drywall mudding. And if you were to buy this aluminum plate on Amazon, it's like $50. It's ridiculous. So I'm always looking for these little cheap things. And so what I'm showing you here is I'm grounded, so that way there's no stray fields, and I'm ready to read the electrostatic fields of the two pizzas that I made. So this is the one that I just heated up. I didn't put it in the charge field, and doesn't have much of a charge. It has 0 so far. So that's interesting. I mean, what's the nice thing about doing this on the aluminum plate is you know for sure whether it's a field or not. If you don't zero out your electrostatic meter, you're just going to go crazy. And also too, this does not work on AC, so don't try to measure frequencies with this. You can't. It only works on a field that's static. Static means it's not moving. So basically, it's like a DC capacitor charged with DC, and that's it. So that's what it's measuring. So that's 30 volts. Now we're going to measure the one I zapped, and look at this. So we've got some charge, and it's significant compared to the other one. because the other one had 30 volts, 0 to 30 volts. This one's holding a charge. It's awesome. And so that's promising. Now, it's not that exciting because I want it to be able to raise all the hair on my body to stick out straight. That's how much static I want. So this is definitely not. And so it worked. It was not exciting, but it worked. All right. Okay. Let's see here. So if you had the chance to read Brent Jarvis's patent application, he talks about unique ways in making electrets, and then also the electrets have properties that aren't really similar to what we have today. And I don't know why. Okay, so I'm back to trying to zap the Geode. Sorry about that. This is short stack. I brought them out because I packed up Amber and Coney. So yeah, short stack. Let's see. We've already gone through these tests. Yeah, so the back of this quartz is chalcedony, and the plasma's not even interested. It just wants to look. You can see that it's zapping itself. That's what it wants to do. Oh, this is the lava rock that I bought. I'm so excited. It's going to do the same thing. No, that those red or orange fingers sort of grabbing it and exploding it, and all this electricity is running through it. But there is something I just noticed. It's pulling all of the plasma into it. I didn't notice this the first time I filmed this. Oh my goodness. It's drawing the entire thing into the rock. So that's new. I mean, I ordered this volcanic rock on Amazon, and I was afraid it's not going to be real, but look at this. This is a real deal. It is taking in all of this plasma energy, but you can't see it going in. Wow, that's incredible. Normally it just sort of dances all around it and kind of looks like it's not even there. Okay, so that's something to work with right there. That's pretty interesting. I know a short stack leaks, so he's got plasma coming out two ways. So yeah, I'm gonna be doing more of that. That's interesting. Oh, so I'm trying to zap my electret. It doesn't even do anything. Sorry, I'm just playing. Let me get to some. So I saw a guy who had a capacitor at the top of his Tesla coil, and I thought, well, I'm going to put a capacitor, and I don't know. I mean, it looks cool. I don't know if it's making it bigger or helping it, but I was hoping it would, because the guy that showed it said it would. So these are, I ordered 200 Petri dishes. You can see them. They're all going to be the same kind of hockey puck size, but you know, midget hockey puck size. And what I'm going to be doing is I'm going to be putting different materials in here to make electrets. And so I just wanted to show you, super cheap on Amazon and perfect for the job. And so I ordered those, and I'm going to be putting the polyethylene, the Teflon, all the materials. And so I pushed away my plasma testing, and now it's time to get out the P, the mica, and these are all positively charged materials that if you rub together, you can have greater charges. Also, there's that fancy wax that Jar Jar said that he recommended. And so here you can see, maybe I can melt it, put it in here, or I can mix it with something and then put it on a shaker and heat it up. Here I'm going to put it in my ultrasound that I picked up at the thrift store. I know it's getting old. Most of my stuff I play with are in the thrift store. Here I'm just going to see if I can vibrate them. And as part of Jarvis's paper is to use high frequency vibrations, heat. This is a little heater module that I picked up from an old, I forget now, thrift store item. So I'm going to be putting stuff here in the tumbler, and I was hoping to get one of these charged from the ultrasound, and so here I'm kind of taping it up with some copper, and I was thinking that it can get a positive and negative charge, just similar to the Van de Graaff generator, but using sound. This is crazy. I'm touching the bottom of the ultrasound, and look at that. The ultrasound has the same wave pattern as a Tesla coil. Oh my goodness. I am so surprised. I mean, this ultrasound is a resonant frequency oscillation. So that's really cool. And by the way, the probe of the oscope is not touching a wire. You're supposed to pour liquid in there and turn on the ultrasound to clean your jewelry. So this really interested me. And so I'm almost wanting to say that there's an oscillator in everything. There you go, and kind of see it again. There's an oscillator in everything. Everything has this sort of resonant part to it. And so that was pretty unexpected. All right, well, that is the presentation. And I'm under an hour, so I'm very pleased with that. Let me see if I can get this. You know, I look better with my camera. Let's see if we can get, oh boy.
What's up, Shawn?
So what'd you think?
Dude, that's so awesome. So everybody had a couple different materials they were looking at, and they were asking if it was carbon that the tendrils were trying to go into.
On the Geode?
Yeah.
That's an interesting answer. I can look into it.
Well, they were looking at the outside, and it looked all black, so it kind of looked like carbon.
It has a feel of carbon too. So it was right in front of me. I thought it was lava rock, but you saw me test the lava rock that I bought online, and it didn't have the same effect, right? The real lava rock absorbed the plasma, all of it, which surprised me. But the geode with the possible carbon coating, that was causing the sort of little explosions. Iron oxide is also black. That might be interesting because it does have a conductive factor. The way it was kind of working its way into the crystals. Do you remember seeing those little tendrils, Nathan?
Yeah, give me a second.
I'll test carbon, definitely. My camera's better, guys, now that I have this big sunburn. No, this is just, I haven't had time to fix it, so.
There's definitely getting negative conduction out of it, that's for sure. He's got a negative element to it.
Yeah.
There's a, what is lava called when it's all dried out? There was a certain name I was looking for earlier. I can't remember it.
Pumice or something?
No.
I forget.
I wanted to say Blythe, but I know that's not right. It's something in that name category.
So when lava cools, it's called, maybe somebody knows.
It's like semi-magnetic material is what it is, and I can't remember the name of it.
I'll write it down, look it up. Dried lava.
Yeah, but let's just go. Oh, basalt. That's what it was. Basalt. You're right, Ian. That's what I was looking for. I wonder if it's that. And it's only because lava's dried around it. You know what I mean? It could be that the lava's all conductive. And when pressure and conductivity, you know what I mean? In one of those things, it's all you need.
But why did the pure lava rock, why didn't it react the same way?
I don't know. It could just be mineral content.
Mm.
because you got to remember lava runs over everything and takes in everything, so it's got
True.
tons of minerals in it.
That makes total sense. Yeah. What did you think about the pure lava rock pulling in all of the energy but not showing any effect? It bent all of those streamers. Did you see that?
Yeah, all to it. Is that the one you're talking
Pulled it
about?
straight in. Yeah.
Yeah, that was cool. There's definitely something going on there that you need to look at.
Yeah. Yeah. Totally.
I mean, I don't want to say this. You don't get that many reactions that do that ever. Like even with metal and stuff, it's like hit and miss sometimes. Sometimes it goes around. Sometimes it hits it dead on. This
Right.
was dead on for everything. So
Right. Right. Exactly. Yeah. I'm still at a loss what to do. I'll definitely be looking through the comments here. Unless you had another thing to share, Nathan.
no, I'm just kind of looking through it myself. Go ahead. Phase
Yeah.
conjugation.
Phase conjugation. Not sure. Not sure. I mean, the carbon makes makes sense because it is conductive, at least partially conductive. But I don't know if geodes are coated in carbon. When I looked it up, it was lava rock and chalcedony. Yeah, so the quartz didn't do anything. Yeah, no, the only thing the quartz did was it drew the plasma streamers to move over its surface, sort of like water running down a stream. And you know how the water goes around a rock and it sort of hugs the rock completely from the top to bottom. It seemed like that the quartz was a rock in a stream. And so the tendrils just hugged it all the way along and and I'm wondering if there's some eddy currents on the other side, if it's moving across the quartz like that. You
Could
know how
be.
you get eddy currents in a stream. Sorry, I can't
So
see.
yeah, right here. Okay. So quartz is negative. Okay.
Okay.
It interacts with the water, is how anything gets into quartz. Without any kind of liquid in there, it generally doesn't do it. So the other funny thing is it always works on pressure. So if you have carbon around it, it could be signs of that area might have diamonds around it or something like that when it's created. Maybe it was, you know what I mean, crushing something in order to create that with pressure. The
Right.
quartz itself has to form, you know what I mean, with heat and pressure.
Yeah, exactly.
Yeah, there's a lot of things around that, man. So it doesn't, you know, the funny thing about any kind of quartz, like we saw the drill press go into it and we see all the energy popping off in it everywhere, right?
Right.
But that's kind of the thing about the earth. And I was telling this to Shawn earlier, is you have to remember, if you look at our water level where it is and you go down to the deepest part and then you imagine underneath that there's another ocean under there, but everything's in rock. Well, you got pressure in that area. Just think about the Mariana Trench and how much pressure's in there. Now put that on a piece of quartz. Now you're creating electricity out of it. And if the outside is super conductive, that makes it even better. Then it gets along to the next part, you know what I mean? Throughout the earth. And it kind of, you don't need, like you can put dirt in between it and it's still going to bring the energy over, around it, or through it if there's water.
Right. Especially salt water.
Oh, yeah.
High mineral content wire. Yeah, totally. So it seems Cheris Rosen is mentioning diamagnetism and vortex. Not sure about the diamagnetism. And I didn't see any vortexes, though. I have a theory about making an electron vortex, and so that'll be in some up and coming videos. I'm drinking some honey tea for my sore throat.
Oh, whatever you need, man.
Thank you. Yeah, talked the whole hour. Guys, I'm I'm so thankful that you hang in with me. It's so awesome. I love sharing everything I'm doing with you guys, and I really appreciate you, all of you.
Ah, single wire energy. That's exactly what it is. So, yeah, I don't think people really understand how important of a breakthrough that actually is. It, it's in the different things that it like coalesces with. It works with.
Hmm.
I was looking at something today, and I was wondering why certain things aren't matching. I was looking at what was it? Oh God, lotus flower, and it didn't match the original signature from the tombs of Egypt, right?
Yeah.
And you got to think about it. So let's stop and think for a second. If we think of Hutchinson and how he did his experiments and how he's changing the flower itself, right? And he goes from a female plant to a male plant, and it puts
Right.
off different buds on the plant. So
Mhm.
now we have to think of it that way too, because they're using cold energy to do it. So they're using the rod down the testicle to do it. That's what
Mhm.
they're doing in order to change the plant. So my
Mhm.
concern is they had that going on with the pyramid itself. So if the pyramid itself is putting off that type of energy, and then you take the lotus flower and have that kind of energy, the properties of it, they say lotus flower is like a drink that you could drink and has healing properties and like
Yeah.
Viagra and stuff like that. And Viagra is just there to open up your vessels in order for things to flow.
Yeah.
So it makes a lot of sense why it would be in there. So it
Mm.
it's a fairly interesting thing altogether when you look at it in that way. They
Yeah.
they had one more thing in there that regular flowers don't have right now.
Right. Right. It's interesting you mentioned flour because that's how I bent the copper on top of the round Tesla coil. Had
I
that
saw
sort
that.
of flour effect, and I put all that stuff on it. And the way the plasma left it was, it was fascinating. I hadn't seen plasma do that by just making a little flour, copper flour on top. So let's see here. Lots of good comments. Eight Sinner says, "No, Nathan, look at the pine cone again. That's how they're modified." Hmm.
That's probably absolutely true.
Dead Fish Cheese Spread says, "I couldn't tell if the flames were like that because of the crystal or if they were in an anti-gravity bubble, but the flames burned down toward the ground, not upward." So yeah, I think he's talking about the lava rock and how
Okay.
they just sort of bent right in
Mhm.
and they absorbed completely. And the rock was cool. I have to do more experiments with that. Eight Sinner says, and the Ankh actually, she can explain it better though. Hmm.
Yeah, we're gonna have. By the way, just so you know, Eighth Center is going to be on Monday again. We're going to do another episode, and it's going to be really cool, man. And then he has a friend who actually has a past life in. Um, oh, it's not Egypt; it's Atlantis. And she says you can remember 1,500 years, Shawn.
Oh
Or
wow.
15,000. I think it was 15,000. It's a lot. And
Wow.
she's going to tell us all about it and stuff like that and explain what's going on there, some of the tech that's going on there. Absolutely fascinating stuff.
Yeah.
So, yeah, he said thousand. See, I'm so excited with that. And then, we're doing the orgonite energy and stuff like that, where we're laying
Yeah.
crystals and everything. Oh, man. We're learning so much more about energy, Shawn,
Yeah.
that I don't even know how to put it all together just yet, but it's starting to piece by piece come together. You know what I mean?
Yeah. I'm getting that sense. I'm getting at the sense that everything we're working on is going to come together and we don't quite know. But it feels like that's the direction. I work with Ian, working with Charlie C. and my goodness, you. And I'm trying to work with Joe. I want to add him to my team. It's just been tough, doctor's appointments and stuff that this week. But yeah, to bring us all together, kind of get us all in the same wavelength. Is that the saying? And we're gonna meet somewhere in the middle. So, do you want to talk about the status of your gravity well?
Oh, we can if you want. It's just I finally got my foot halfway better, and then over the next couple of days, I'm gonna have it cut, the frames together, all that goes together, and we start spinning by Monday. That's
Nice.
my goal. So no matter what, I don't care if my foot falls off way, then I'm gonna have this thing done. So
Nice.
yeah, but all the parts are already there. Everything cleaned up, sanded up. It took forever to sand this stuff, by the way, because everything's such a tight fit that any little burr or anything's in the way. When you start sinking in the insets, you get a little extra on the end, and you have to take a razor blade and cut it off and clean it up.
Right.
I mean, just normal stuff. I mean, this isn't anything new. The fit on it's pretty good. Pretty happy with most of it. And, we're going to start spinning it up. Shawn, this thing is going to be insane.
I am so stoked.
Yeah, I'm stoked too, man, because there's a lot of different ways in order to create this stuff. And this is one that you can actually see, understand, makes perfect sense with the world.
Yeah.
And the way I created it with the extra piece on the outside, you actually get to change it out with anything you want.
Nice.
You have exact specifications in the program that somebody can follow and bring you the part, or you can give them the plastic part to match it. You know what I mean?
Yeah, I can't wait to see it. You're going to share all the stills?
Yeah.
STL files?
Like I said, by Monday we'll be spinning it, and
Nice.
and I'll be showing the updates on it and stuff like that. Take a few readings on what's going on with the magnets and stuff, and yeah, dude, it's gonna be crazy. It's gonna be one of those projects that's around for quite a while because there's so much to do to it.
Yeah, I think it coincides with your Graviflyer research, because you're creating a gravity well, which is basically a type of manipulation of gravity, at least. What a starting point would that be to warp gravity? I mean, that's a huge step.
Well, you have to think about it in how the gravity flyer works, right? You have a static field being held in by a radiant field. I'm going to do the same thing. The only thing is I'm going to create multiple capacitors in it that build on each other. And yeah, it's going to completely change how we see things, because I'm expecting to see a field on the outside of this thing eventually at some point.
Yeah.
So I'm going to find any way to find it. I've been looking into it to see. Joe's been sending me stuff too for curved mirrors.
Some
of that stuff, because they're able to see liquids that you can't see, or gases, I should say. And with the blue and the red colors, stuff like that. I also wanted to look at doing red light, but then take a curved lens and put some kind of fluid in there and then trap it in the middle to see if I couldn't see through that the same way like your eyeball does.
Yeah. And that's all to see fields?
Yes. Look, there's got to be a way to see it correctly. You know what I mean?
Yeah, that's...
So right here, I can't say that word.
Chiller.
Yeah, a camera. So if we could see the fields and everything, Shawn, you could see the fields coming off of you. We could see the fields coming off of me. We could see the fields coming off the gravity flyer, everything. Then the world is just in our hands. We could do whatever we want. It's Now we can manipulate it. We can see to make it stronger, make it weaker, which things work,
Right.
but don't. Now we can start manipulating it. And if there's anything that shows up in there geometry wise because of the frequencies going in, we get to
Yeah.
see all of it.
I found a material. 1 second, I'm gonna go grab it because
Okay,
this
go for it.
item tells you what fields look like.
That's interesting.
So here it is. It's for aquariums. It's for aquariums, and it's called potassium permamagnate. It's for cleaning aquariums, I think.
Okay.
I've been experimenting with it. It's a powder. And if you put an electric field next to it, it just goes flying in the direction of the field. So I'm going to figure out a way to try to slow them down. And that way, then it'll show exactly the field on a two-dimensional. I'm going to do it on paper. And it's amazing. It's amazing how these, and they're little, almost like rock bits. They're like little pebbles. They're not, it's not a powder. So when they leave, you see them leaving the field, and they're only affected by electric fields. And what's strange, one of the things that's strange in my testing is if I use a positive, they go flying in the angle of the field. And then if I take another polarity, so I do negative instead of positive, they do the same thing. Yeah, I don't get it. It's a strange material, and in my research, so I'm going to see if I can see some fields with this, and then let you know. It might be worth considering because I know you're interested in seeing that.
Shawn, I've been trying to see this thing forever. Let me just tell you that. It's the hardest thing to know it's there, but
Right.
knowing it's there, and then somebody not standing in the same room with you, they don't know it's there. So
Yeah.
it has to be something that's conveyed to everybody, because once everybody sees it, it's like, oh, okay, now we're there, right? Now we have a place for everybody to go to, and then they can start doing the math on it and work it out, right?
Right. Yeah,
So,
sounds good.
I mean, yeah, gravity, by the way, is about frequency. And it should just be said this: frequency creates the vortexes, it creates everything. It's really how you understand frequency. And Shawn and I were talking about this earlier.
Mm-hmm.
You need that ring. That ring's in everything. How you build that ring has to be very specific.
Mm.
And it's got to follow a scale. And we were talking about quartz earlier, and it's got 6 points, and every one of those points is a different frequency, but the frequency follows a scale as it goes around.
Right.
So, you can look at it in fractal geometry if you like. It does the exact same thing.
Right.
You know what I mean? You do the wire coils, does the exact same thing. When you do it, the inside of a geometry coil, by the way, is negative. The outside is positive. So then you're getting the heat and cold to operate your system for you.
Wow.
So much more special, man, than people think it is. And yeah, that whole frequency thing, man, and I only know it because I took my Tesla coil and did the distance with just a secondary and found the plasma in it. Once you find that, your whole idea of what's going on changes.
Right.
There's so much more energy in a lower voltage than people think there is, because frequency brings the rest of the energy for you.
Right. Exactly. I'm working on getting a coulomb of charge, and that a coulomb of charge is just 1 amp for 1 second, and I think it's 1 volt. And the amount of energy in a coulomb is astounding. And I mean, it's incredible. And that's where I believe you can get a lot of dense electric fields in a coulomb. I really think that's an avenue. And if you Google it, how to create a coulomb of energy, oh boy, AI will tell you it's not easy, or you can't do it. So, but yeah, it's just it's a unit, or a container, if you will, of a number that's super crazy high of electrons, super crazy high. So it kind of goes along with what you're saying, is it's not just high voltage. This is 1 volt, but the Coulomb is super powerful fields. So I know Ian and I were watching a guy by the name of his last name's Pias,
Okay.
Pias, and he was talking about how containing a very dense plasma using a magnetic field, that it can break or destroy the barrier in the 0 point energy. And he talks about how you can get that enough energy to power those UAPs, those UFOs, because they're so fast, they kind of break the laws of physics.
It's about Sal Payas.
What's that?
Sal Payas?
Salvador Pius.
Yes.
Salvador Pius. Yeah. He's the real deal. When he said he got a patent for the UAP, what is it? UAP propulsion. Oh my goodness. I want to read all of his papers. I want to break the barrier of the 0 point energy. I mean, that just sounds crazy. Crazy.
Well, I could tell you it's already been done.
What, you and Gerald?
Oh, it wasn't me. Not by any stretch of the imagination. It's Gerald.
Okay.
He did it.
Mhm.
He's got something special on his hands, and there's no getting
Wow.
around it. And I know everybody wants the secrets, but you know what I mean? I looked at both, man, and I just saw how they worked and the way
Mhm.
Sal describes it. And there's so many things, Shawn, when you look at this, if you see
Yeah.
all the interviews and stuff, do yourself a favor. Just take it, put it in an editing machine, cut out every question from every person that asked it, okay?
Okay.
Cut out all the hee-haw, all the extra stuff in there. Cut it all out. Get rid of it.
Okay.
There's about, in a 2-hour interview, there's about 15 to 20 minutes that you need to capture.
Yeah.
And it's very specific what he says. When he starts telling you that there's geometry forming on the outside,
Yeah.
now I want you to look at a crystal structure and how it forms a geometry on the outside. Now, just think about how that works, okay? In order to get that geometry out there, you're going to have to create frequencies, just like I told you, 1, 2, 3, 4, 5, 6, in order to create that geometry, which creates the geometry of the outside, which matches the crystal.
Mm.
It's all one thing. And you have to think about it like this. He's taking a radiant field, which is radiation, and then he's pushing that against a static field, which creates a plasma field in the center of it.
Okay.
Now, you have to rotate that extremely fast. So you can't do it with simple rotation on a plate to create what he's talking about. Now, can you still get anti-gravity effects with slower plates? Yes, you can.
Okay.
But in order to create what he was talking about, it has to be in a geometry type coil. It has to be super fast. And it has to have 2 coils in one, at least. 3 coils in one would be better in some circumstances. But yeah, Sal Paya's whole thing is Gerald's coil, and he's defining what Gerald did.
It's incredible.
It's insane how much they match, because when you start doing the testings on stuff, you're going to start to see it. There's a lot more things that, oh man, I can't say everything. All I can say is there's a lot more to it.
Yeah.
But man, it's scary. Scary when you start looking at he starts talking about the Planck scale. That's important.
Yeah.
And the field on the perimeter is the exact same as the field on the inside.
Yeah.
So think about it. We said static is being held in by radiation, which is creating plasma. Well, now put it in a confined area, you have the exact same thing. What does that mean? Well, since static is created by something you can't see this field, right?
Right.
But if you put something down the center of it, you can pick up the energy from each individual field that goes down it.
Yes.
And then you could see the accumulation at the end will be in the thousands versus a few hundred. You know what I mean?
Yeah, nuts in the rod, you're saying, is collecting those frequencies.
Put it right on a ferrite core with wrapped wire on it. Put it right down the center of it, and you collect it. Ian's done the experiment too. He's got quite a bit of voltage out of there. But yeah, he's done one of them, and he's done really well with it. It's close, but it's not there yet.
He's getting close to Gerald's little ferrite coils that he puts in all these different places, and they create all these different voltages, and you're scratching your head. How is he getting all that energy out from these little ferrite coils? Real quick, 8th Sinner talked about I should look at a patent from 1997, and then his comment disappeared. Did you see that?
I saw something about it.
Yeah, I kind of want to not miss that.
You need to get the 1997 field propulsion patent.
Field. Thank you. I'm just writing it down.
Field propulsion is directed energy.
Totally makes sense.
Well,
totally.
It's
yeah,
I can forward it to Nathan for you. I'll send it to you as soon as he sends it to me, Shawn.
I appreciate that. Thank you so much.
Oh, also they wanted to know where they can read Jarvis's patent.
Oh, good question. Jar Jar's not on this.
Is it on his website or his YouTube?
Thinking.
I know I have it in archive. I'll have to look at it.
Yeah. I know if you commented on his video on YouTube where he talks about it, he'll probably send you a link. I mean, I can reach out to him directly. We message all the time. But I don't know where I just send it to you and then get it out to the chat.
Yeah, send it to me and I'll send it out. I'll put it on the little note thing. You know how you do the thing for YouTube and you have notes and stuff?
Yeah.
I'll put it out right there.
All right, sounds good. I hope that's a good place for these wonderful people in the chat. So we got some comments here. Good conversations as usual. So John Brigham talks about type uses just the sharp edges of the voltage squared. Bifilar creates zero potential for single wire experiments. Negatropy, that's from Zen Peak. Dead Fish says like cheese, like cork, sorry. I'm just trying to get to an answer or a question here. Let's see. Interesting stuff, guys.
Yeah, the bifilar coil, the flat pancake ones, they're not good for creating the field. They're great for taking in the field. If you want to take in some radiant energy into it and pull in the energy from the room, they're absolutely amazing at it. They hold the energy in quite a bit better.
I wanted to build that massive 10,000 turn bifilar, and I'm back to square one. So, but I was able to actually get some arcs and sparks from it. I thought I had in the presentation. I'll just bump it up, but I got that pancake throwing some plasma. It's weird, very weird to get working. So Dead Fish says, can patents be hypothetical? No. Well, yes and no. you have to take your hypothesis to a group of experts, and then they determine whether or not that your hypothesis is credible, and does it have sound math and sound um, it's sound science. So when Salvador Pius, when he tried to get his patent on the propulsion system from 0 point energy, he got knocked down a few times. He'd have to go in with a group of physicists, and he would have to basically defend his hypothesis. And then finally he broke through. Finally, he got a group of physicists that were no joke. These guys are smart people, but they very, very incredulous. Very, yeah, no. They didn't think it was true when he came in, and then he left. They said, yeah, I mean, everything works out. So it's interesting too because he's works for the government, so he can't tell us his recipe. He's a part missing for security purposes for our country. Man, I'd love to have that missing piece. But yeah, and so that's got me very interested because I want to contain plasma with magnetic fields to get the plasma more intense. That to me just sounds amazing.
It's not. Oh man, it's not the magnetic field that's doing it.
Oh, uh-huh.
Like I told you, it's radiant energy versus static. That you got to think about how that works. It's not a magnetic field like you would think. You can't. It doesn't work that way. Magnetic fields do not work that way.
Okay.
They do not hold it in like that unless you put it in a very massive amount. And that's not how this one works. So
that's interesting.
It's fields. It's how they held it. You could do the test, Shawn. It'll show you rotate a field with your Tesla coil. Just take a motor and spin a plate. Put the energy on the plate. And once you do that, put your static electricity on it.
Okay.
Then have like a surrounding area to it. And you could just create something that looks like this. You know what I mean? That caps on the both sides, but it has to be rounded. Okay. Or, you know what I mean? A plate that it goes to or something like that where you can create another field upon it.
Like a toroid shape.
Yeah. Just something where you can create it on the outside of it.
Okay.
And then all you have to do is put your Tesla coil, put the rod down the center and hook it to it. And you'll hold it in. Then reverse it. Put the Tesla coil on the rotating disc and the static field out there, and it'll fly across your room to everything.
What?
Yeah, super fast too. So you got to watch out to keep it at very low voltages. It'll just blaze your whole room real fast, and that's how you know. That's how you know what's holding in the other field, and pushing the other one out.
What size are you talking about? Just is this very small? This where the charge is built up on from the Tesla coil and the static field.
Oh, we're talking 20 volts.
Okay.
I mean, we're not talking anything more than that. The static is two DC flybacks connected together in order to make the static electricity. On mine personally, I use the trigger circuit along with a frequency generator in order to change the frequency of the DC flyback so that I can get more static electricity out of it.
Yeah.
So I was showing you the circuit earlier. It completely changes your understanding of how this works.
I know.
But then you're tuning everything to frequency in the gravity flyer anyway, so everything has to be tunable. Otherwise, it's all over the place and you'll never find it.
Right. I really want to know how that trigger circuit works. That's the fascinating part.
Oh, right here. Maxwell's equations. Okay, so Joel Legacy, from what I understand, wrote the other side of Maxwell's equations. So
interesting.
The negative side, he wrote it so that we can quantify now the negative side into it in order to make the Oh man, what do I call it? I was gonna say quantum, but that's the wrong word.
Hi, Mike.
It's to create the ether.
Mm.
In order to make the ether work through Lorentz, you had to have the negative side of Maxwell's equation.
Okay.
So defeating Lenz's law, things like that, because Maxwell's equations only deal in a magnet.
Right.
It's basically what it is. It's the definition of a magnet. But
Mhm.
when you get to the other side of that, it's what you need. And then you can
Electric
create
field part.
the whole negative field, the one I always use in my Tesla coil, stuff like that, radiant energy, all that stuff, because it'll give you positive radiant energy out of the Maxwell, but it won't give you the negative. And it's a whole missing part of everything. It's like the final piece of the puzzle you'll need to really quantify what you're doing.
So, I just wanted to finish my note here on the Tesla coil spinning and then adding the static field. And this is to some plate, some piece of metal that is going to hold the charge from both.
You're basically, yeah. So you could do it spinning plate, flat plate, spinning plate, right?
Okay.
And then I put on both the spinning plates. I'd be able to put the Tesla coil on there, right?
Okay.
And then on the flat plate in the center, along with the little bars on the outside, it was a static, right? So the other way to do that is to find yourself like a quarter of a donut. It just looks like this, and it rounds out around it, and then put the spinning disc in the inside somehow, and then you can create the same fields out of it. That's it. So
you said you put the flyback static electricity on the middle disc and a Tesla on the top and bottom.
Okay, so again, you got to think of it this way. The Tesla coil field has to hold in the static field. So if the rotating disc is in the center, right? So you want the static there, but then you want the Tesla coil energy on the outside, which is the negative radiant energy, right?
Right.
Now, you want to switch it, then you put the Tesla coil on the rotating disc and then the static field on the outside. So you think about it, what do I want to do here? I'm just trying to push the static out. So from the center, it's pushing it out.
When you switch to the center with the Tesla coil, do you put the static on the top and the bottom of the other discs?
Yeah. There's a positive on top, negative on bottom.
Okay.
And negative is also your grounding.
Okay.
So that's why they have the magnets there, because it acts as your grounding. But that's just for a different experiment.
Okay.
This is just something very simple, yeah.
Yeah.
No, it's got to stay on the bottom. So a lot of people don't know that. It can't go to the top. As soon as it does, it fails. It's game over. Positive has to stay on the top. And you need to, there's a lot of stuff to it.
Yeah, this is a lot of stuff that is easy for you because you've worked on it so long.
The hardest thing is to realize that you're dealing with frequency as it goes up that ring. And as soon as you realize you're doing that, and when you put the top and bottom disc in harmonic balance, okay, which means they don't have to be the same frequency. But if it's say 800 on the bottom, right?
Yeah.
And I put like 1,000 or 1,200 on the top RPM, the frequencies are going to be in that same thing. Key of A, key of A, key of A, right? So from my understanding, that aluminum falls in the key of A, and you need to reach the 4th octave to get there. So you need to manipulate that ring to do that.
Interesting. When you talk about, are these sound waves or are these vibrations in the materials?
It's like I took your oscilloscope with your ring on it, and I broke it into pieces. That's all it is. It's pure frequency.
Say that again. Sorry.
It's like I took your okay. You see how on your oscilloscope you show the ring and it looks beautiful, right?
Yeah.
Now every time it dips down to the bottom or it comes to the top, I just
Mhm.
want you to draw a little line and write the frequency of that. That's what I'm doing.
Oh, okay. Makes
So
sense.
I'm breaking it down to every octave I hit. Okay. And then
Mhm.
I'm taking that capacitor that's in the center where you can create light out of it because it has everything in there. And I'm forcing it to push and pop it.
Okay. Interesting.
I'm sucking in a ton of energy from the environment. A ton of it at one time.
With this idea of sucking energy from the environment, what did you think of the geode taking in the energy on top, but then feeding the energy back to the coil, the sphere? That surprised me because I didn't have any rocks go back to me. Take in the plasma and then give it back. I mean, you could do that with metal, but you can't. What you're doing with a rock? That's crazy.
Yeah, I'm telling you, there's a whole thing here, Shawn. It's not acting normal. You got some minerals in there that it's
Yeah,
working with.
I have to figure it out. I will. So yeah, it's potassium pergramate. Yeah, someone just wrote it in the text in the chat. That's the
So,
stuff that reacts to fields everywhere. It's crazy.
so hold on, Shawn. I got a question for you on those electrets.
Uh-huh.
You guys don't have a pourable liquid that you put into something and just run the energy through it until it dries?
A portable electric, is that what you
A
said?
pourable, pour.
Oh, I mean, that wax is pourable. If I heated up the polyethylene to be hotter, it'd probably be more pourable. It's just a heat thing. The hot air gun was ridiculous. Heating it over the stove is an inroad. Ah, okay. But then there's a way to do it in the microwave, and I want to get it to a liquid form. That way I can just pour it in, uh, heat it up till it's liquefied, and then put it in my electric field. Those two plates that you saw, that was for me to just get my feet wet because I haven't really created an electric yet. And technically, that lousy, burnt looking little ball of gloop, it carried some voltage, carried a couple thousand volts, which the control, same thing was done to it, except no electric field, and that had 0 volts. Now, electrostatic meter is pretty precise.
Right. So that's why I'm wondering what material do you have to buy in order, like the plasma channel, the little pucks, right? So what did he
Yeah,
use?
he he used polyethylene. He used that wax. Wax he used first with resin and some other material. That worked, but then he used polyethylene, and that was so powerful it caused all the hair on his hand to stick out. So it had that much charge. That's what I'm using that material, but to not do it so much as melting it like him. But I want to put them in a tumbler and have them touch each other and scrape enough electrons or protons to the point that they're so charged that I have to figure out now how to put something to bind them together to hold that charge. And then that's basically what Jarvis's paper is. It's not about putting it in a field, it's about friction. And if you could rub every part of every little speck and charge every part of that, and you get 10,000 little electrets, it makes a massive field. And the key now is that now that I'm getting comfortable with the physics of it, I'm going to work on pushing out all of the of one thing. Let's say I'm going to push out all the electrons. Okay, I'm going to start, let's say, from the center. And then it literally becomes one giant, oh, let's say I push out, not the electrons, I push out the protons. If I can push out the protons, then it becomes one solid negative charge. And so you have a static electricity trapped in an insulator, but it's a negative charge because it's all electrons or all protons, however you want to make it. That's the hard thing to do. That's the thing that's in his patent.
Okay,
Then
so just let me get my head around this. You need to create them so they're mushy, and they get the electrostatic stuck in that mush, and then harden again, right?
basically,
So you're basically looking for like a popcorn machine heat wave to go in this, right? That's it.
that's a good analogy. Very good analogy.
So
it's moving, it's heating.
you would need 2 PVC pipes, and then you want to tumble the stuff in between the 2 PVC pipes in the spacing, that little spacing.
Yeah.
And then you want to blow in heat so that it softens the material. And then on the outside of the PVC pipe, you want to put some tape or some, you know what I mean? So the electric tape, not electric tape, I'm sorry. Like an aluminum tape.
Yep.
And then charge it with only the positive, right?
Right.
So you do that, you get a big positive field going on. You got the heat in there to mush them, and then everything takes on the charge, and then you keep tumbling until it's cool. I mean, does that need to be cool right away?
No, the slower the better, because the longer that it's in the field, the more it aligns its molecules to be charged. So they're all going in the same direction. So that's why it's actually better to have a slow cooling, because it stays in the field longer, and not a fast cooling. And so, so when you're talking about heating it up until it melts in between the pipes, it's a really, really fascinating way to look at it. But how would you get it out of the pipes if you melted it? You couldn't, because it would just stick like super glue. This polyethylene, when it melts and sticks to something, you you need a pry bar to get it off. It's really strong stuff. So you're on the right track though. You're mixing heat and you're mixing movement, and that's part of how his patent works. But now you need vibration, and you need a way now to bind it together, so without leakage. Leakage is the enemy. When you rub static on something, let's say you drag your feet on the floor, you could sit down in a chair, and in about 5 minutes or 3 minutes, you've leaked out all the static charge. You don't have it anymore, because static electricity goes in the air, goes everywhere.
Okay, so hold on. Frequency and vibration comes in the tumbling itself, right?
Right.
So if you injection molded this thing and then charged it, inject and mold it, plug it, run it, you know what I mean? Let it cool down as it charges, you may have it.
So that, I'm going to look that up because that sounds fascinating. Let me write it down.
Because injection molding is all about filling it right away with the plastic that's hot and liquidy, and then you rotate it and tumble it and charge it.
And build a super, super massive charge. The key again, though, is if there's anything in the injection molding process that supplies even the smallest amount of leakage, that's the enemy right there, is leakage. You can, you pull your socks out of the dryer and they're stuck together, but that's it. Once you pull them apart and put them on, there's gone. It's leaked out.
Well, a little bit of Teflon tape, a plug. You know what I mean? Have it ready to go, right in there, set to go.
I mean, it's worth looking into. I don't know a lot about it.
Tape, blue tape. You know, your 3D printer used to be old school. You put blue tape on it and you print on top of it.
Yeah,
And
the
then
painter's tape.
the plastic goes on there at several hundred degrees, right?
Mm-hmm.
And then when it cools, it pops right off the tape.
Mm. Mm. We'll look into it. Thank you so much. All right,
Yeah,
we got
if 3D printers wouldn't freak out, I'd just tell you to 3D print it with static, with the static field on it. But then you blow up your 3D printer.
yeah. I mean, you, you need a map. Oh yeah, the strength of the electrostatic field for the 3D printer. Yeah, it would destroy the electronics. Yeah, but that's interesting. A lot of people are throwing things out here, using induction cooker to melt it. One pole, dielectric between two halves.
Parchment paper might work.
What? Say again?
Parchment paper, except for it when you go above 400 and something degrees, it starts to brown and to fall apart.
Yeah, trying to stay away from organic, because the the manufactured pure, different types of dielectric or insulated materials perform way better. And I mean, it's like taking silk and rub it on a PVC pipe. You're going to build a nice charge, but after time, the silk's going to deteriorate. And so that's the concept about the injection molding. Sounds really fascinating. I have to look into it because it sounds like it could put it in a huge field. And like you said, put it in, inject it. Interesting. Dead fish says one atom layer of graphene at a time. I've always been interested in those sputters where it's a vacuum chamber with a cathode. It's all homemade, and it lays down one atom layer at a time using plasma.
Oh, Shawn, hold on. We just talked about doing all this stuff with hot. No.
Thank you, Cheris.
Okay. If you're going to use something like graphene as a thing to charge, then you definitely want epoxy.
Yeah, I mean, I didn't even think about graphene because it's expensive.
Yep. But it's the cold epoxy that makes it easier. You don't have to have all the massive heat. But then graphene would give you the charge you needed, right? And it's a multiplier.
Yeah, epoxy's on my list. It's on my list as a binder. So if I can charge a lot of polyethylene and put it inside the epoxy and then charge the epoxy with the polyethylene, and I sort of lay those two layers of charge and then let it cool as slow as it wants, under an super intense electric field. My Van de Graaff generator didn't have an intense electric field. I just needed to get it all sort of working in my head. And the fact that I had a little ugly looking blob of electret, now all of a sudden I have all these big ideas. So yeah, I really want to do epoxy. I'm really working on a super intense electric field. It's not easy to do. It's not. I mean, you got to do some serious know-how to get that kind of intense electric field.
What if you just created a Tesla coil? Just hear me out on this.
Okay.
And you have it running while you're putting on the epoxy resin. 9 volts, 10 volts, something simple, Slayer exciter circuit. Just run it through there, right? You're getting mostly static out of it anyway. You know what I mean?
Are you talking about connecting it to the center rod of the Tesla coil? Is that what you're saying?
If you just epoxy the Tesla coil while it's on. So if I were to set up a Tesla coil right next to the Tesla coil you're putting the epoxy on, right?
Okay.
And I didn't have to hook up the primary to it at all. All I had to do was have it sitting there, and it picks up the frequency of the other coil to run it, right?
Right.
Now you can have it running and the epoxy covering it and coating it. Would it keep the
Oh, on the
charge in it?
rotisserie.
Yeah,
On
would
the
it keep it in it?
rotisserie. I got to write that down. That's fascinating.
Because now you don't have to have anything on it. You just have to activate the frequency of it. Would it put the charge right directly into that epoxy?
Yeah.
Or could you, like you were talking earlier, bind the epoxy with something else on the outside?
Yeah. I'm thinking polyethylene or mica. I have mica powder that's used for cosmetics. So, I mean, there's stuff to add. I have Teflon. I have nylon.
Oh, there you go. There you go. They're perfect. It's just like building a patch for your tub. You put on the nylon, right? And then you hit it with that coating of resin. Okay, or in this case it'd be epoxy. So it's just like creating a patch on your tub. That's if you can charge that stuff in there, it's kind of like muffler tape. You put it on there and it holds it, and then you put on the binder that holds the charge inside of that. You see, the testicle doesn't even have to be part of it. It could be inside the thing as well. It could be the thing creating the energy on the inside, so you don't have to touch anything to it. There's a lot of different ways to do this.
Yeah. I've got 5 sticky notes now.
Sorry, I get a lot of ideas. Some of them may not pan out, but at least they're, you know what I mean? We're inventing different stuff.
Yeah, it was all great ideas. It's awesome. Guys are throwing stuff out too. So potassium permanganate, I can't say it, to make electret particles. This is from Neg-Res Coils. That's an interesting theory because they're super hyper reactive to charge. I mean, I had a little teaspoon of it, and I thought, okay, well, what are these guys going to do? And I just brought the tip of the Van de Graaff generator positive, and I just started coming close, and they disappeared. They went so far, they just gone. They're somewhere stuck on the wall or something. These guys hate charge, but I wonder if that's because they have charge. I have to do more experiments.
And those little balls you're talking about?
This aquarium.
Oh, okay.
Yeah, it's in the chat a couple times. It's like, I don't know, $10. But oh my goodness. I'm gonna see if I can get it a little wet. So then as it leaves, it's sort of weighted down and it can give me my fields. So a lot of talk about graphene here. Yeah, graphene is amazing, but it's incredibly expensive or hard to make. So here John Bigham says, take a hockey puck and mold it with silicone mold material with 2 plates on either end. Make each half electrode with silicone mold materials that clamps. Together, feed plastic in the mold. Charge. I mean, it sounds like a good idea. It sounds like it would work. I guess it sounds like your injection molding idea almost. So thanks for that, John. Fumed silica, Deadfish says. David Williams says graphene infused paraffin wax. The whole graphene thing I can't do. It's too expensive. Long chain molecules. See, Deadfish says they use fumed silica and polyurethane to make it thicker. Fumed silica. Have you heard of that? Interesting.
Yeah.
So here, Eric says, you seem very familiar with the ion craft stuff, Nathan.
Oh, I am.
He's very.
I used to build in the beginning of my channel. You'll see plasma displays, like a little halo bridge at a plasma. or rotating plasma on a disc, things like that. All kinds of different stuff. I built the ion thruster from Plasma Channel. I did that one. All kinds of different experiments with high amounts of electricity or static electricity, and then ion wind, stuff like that. And I understand how to multiply it and keep it going. It's just there's not enough on Earth's surface to make that stuff work. It's just not possible. In space it does, but they have to add gas to it. So they're doing something different there than what they probably tell you. They probably have a meg in it and are multiplying the static electricity and building a vortex. So there's different things that they're doing on there. I doubt they have a bunch of gas up there for 1,000 years.
Right. Yeah, if they can do a vortex of fields, they don't need a medium like gas to make the plasma, because you need fuel for plasma. So we use the gas. That's what my Tesla coils do. They used to use the air around it, and there's no air in space. But if you could have plasma wind in space, it would push the biggest ship because there's no gravity, right? You don't need a lot. You don't need a lot of push.
That's kind of the point of the field, Shawn. You have to create a field in order for some of this stuff to work out there. That's why the field, you could push your hands through it. Okay? So, anyway.
Yeah, no, makes sense. I'm sorry, graphene. People are saying graphite is cheap. Use coal and tape. Yeah, so graphene is not graphite, or graphite's not graphene. Graphite's in your pencil lead.
Yeah.
It's the contacts in motors. DC motors have the thick graphite because it conducts. Commutators, they're for motors. So someone said you could take a welder to graphite and make graphene for cheap. That's Tommy guy.
Oh, Mike Faraday. He has a video coming out on graphene. And I think he converts graphite into graphene using the ultrasonic cleaner.
Oh, really?
So, I wanted, he has a video. He was talking about it last week on the live. So if I see that, I'll forward it to you.
Please do. In fact, Mike says graphene is easy to make. Just get an ultrasonic cleaner, mix 75% alcohol or methanol and 25% water, and cut it in the ultrasonic cleaner for 48 hours. All right, so I'm going to save this here. But what is this cutting?
I'm not sure. That's why I wanted to see the video.
Yeah, I want to see it too.
Well, he's working on those batteries, so he's got more knowledge than you and I on it.
Oh, I know. He's the motor guy. He's the generator guy. Guy can generate electricity in a zillion different ways.
Robert Murray Smith, which is an absolute excellent channel, by the way, has a video making graphene at home.
Let's see. SNA just joined. Curious if you know of a coil that will produce either 2 north sides or 2 south sides out on the coil. If you're talking about a magnetic field, no. There's always a north and a south. There's no, you can't have 2. If you could have a monopole magnet, you'd win the Nobel Prize in physics.
What is that? Just a North Pole or just South Pole? Is that what you're saying?
Yeah, you only get a north and south. Now, if it's a electric field, yes, you can have a positive on one side and a positive on the other because it's a positive charge. So if you get a proton positive charge or you get electron negative charge, That's it. There's no north south. There's no positive negative. It's all one. It's all one charge. Thank
Interesting.
you, Cheris. Captain Shawn. She keeps saying, or he keeps saying Captain Shawn.
Oh, when you do the emojis, watch. Okay, hold on. I'm
I'm
gonna
not
put up.
seeing. Oh, I'm not seeing the emojis.
Yeah, so I put up Shawn right now, right?
Okay.
So when it comes up and you see it here, it says Shawn, 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 right?
Yeah.
But on the other side, it has a little emblem of you in your face on the
Oh.
live.
Oh.
Yeah, so it's kind of a way for everybody to interact as a member in the chat. And by the way, guys, I just wanted to bring this up real quick, Shawn. I
Okay.
gifted 5 memberships today. So I wanted to show something if you don't mind. It just takes a second.
Yeah. 5 memberships today. That's awesome.
So these are the new members right here.
Wow, that's great. All right. Thank
So,
you, guys. That's so awesome. And if you missed the earlier presentation, SNA, a lot of great plasma experiments if you want to rewatch this.
oh yeah.
So Cheris says hydrogen peroxide reaction, potassium, that permanganate convection. That's interesting.
So here's what Mike said. Ultrasonic exfoliation. Mike, is that a video that you have out right now? I know he was talking about it.
Sorry, I'm writing it down.
Yeah, no problem. Yeah. Well, whatever's going to help in you guys' research, absolutely.
Oh, yeah. Oh, he's a wealth of information. He's so smart.
I honestly, I think Mike should do a segment on his channel, man, of him just doing history itself on like people that like heavy side and stuff like that. 30, 40 minutes on an inventor like that. The guy is so smart about all that stuff. So
He's built so
that'd be
many
awesome.
generators. Yeah.
Yeah.
And his builds are clean.
What's more than that, it's his knowledge. It's right on the top of his head exactly what they did. You know what I mean? I think that's awesome.
Yeah. So a lot of talk about exfoliating graphene. So I'll get the exfoliator in my bathroom and I'll start scrubbing some graphene.
Give me a sec. I'll look at it while you look at some more chat questions. I'll see if Mike has it on his channel.
Oh, Robert Murray Smith makes graphene. Huh.
I love that channel.
His wife just died. It's so sad.
That sucks.
He woke up and she passed away in her sleep, and totally unexpected. And it took him out of commission for a few months, and now he has that picture behind him in his presentations of his wife. Yeah, super sad.
Okay, Shawn.
Mm-hmm.
I'm going to share the video right now.
Okay.
Mike's got it up on the site.
Yeah, Tech Ingredients makes graphene too. Thank you, Dead Fish.
So, and then before I forget, I'll just send it to you on your Facebook real quick.
Okay. I feel like I'm in the plasma chamber. I'm turning purple. Well, you can see more of my face, I guess.
Right on. There you go. I sent it to you. There you go. The chat has it, and also I send it to your Facebook. So you're good to go.
You're awesome. Thank you. Appreciate it. All right. What do we got here? Let's see. Oh boy, we've been here 2 hours already.
Yeah. It just flies by when you're having fun, Shawn.
I know. I can tell though my throat is closing up, and I'm running out of tea. Wow, I'll tell you what, Nathan, I can't thank you enough for letting me be a part of this wonderful work you're doing, bringing like-minded people, giving them a safe space, really, and not in the victim form, but more of a place to share ideas and just not to be judged, not to pick apart their language or parse their syntax while they're talking, but to just let it out. We get the gist. I mean, we're not dumb. We have intuition, we have common sense, and we're sort of bouncing off each other like electrons, learning from each other. And yeah, we're gonna get to some special place. I really believe that.
Well, it's what it's going to take, isn't it? I mean, that's
Yeah,
the whole goal of everybody else out there, and they confine themselves to a box. And I just said, well, let's just
yeah,
throw the box away. You know what I
yeah,
mean? Bring everybody in and see what you got. You never know which experiment matches the next one.
yeah,
And I found that to be so true, man. Like, I never thought, Tesla coil and then geometry coils. I never thought, you know what I mean? Like crystals. And I never thought too much into it until, we started getting into this thing,
yeah.
starting to figure those things out with the energy going on there. If you don't have a well-rounded view of the entire world, it's going to be very hard to put it all together.
Right. That's the key. We could take data from all around us and sort of match it up. And a lot of people just become experts in one area. They don't really take everything around them. And that may not be related to this, but if we put it together, it actually has something that we didn't expect. And that's what I like, because there's this sense, and I've worked in pharmaceutical companies for 17 years, and I worked with very smart people, PhDs, and they tend to just go deep in one area, but they can't expand. They can't just, and I don't think they promote it. I don't, in school, I don't think they promote, hey, you know what? Challenge everything, throw all of this out, and then just go for it. And yeah, I couldn't spell Tesla coil a year ago. It's been a year since I met you. I had
Yeah.
no idea what a Tesla coil was a year ago. And I mean, I've got plasma everywhere. I
So,
mean,
Shawn, I remember I was burning mine up. They were on fire.
I love that. I love that. What do you think of the power that comes out of that sphere? Is it insane?
Dude, it's awesome. It's the only way to say it. It's awesome. And
Thank you.
oh my God, dude, the fields that you're putting out of that thing and the way that they're built, it's more than just it's how it matches what Tesla saw in his head
Yeah,
about the actual fields and how they're built. It's so amazing. It's
right.
You got like a whole thing going on here, Shawn, that
I
you know
appreciate that.
I just want to make sure you get enough credit for it because you absolutely have an amazing concept.
Thank
I'll tell
you.
you, when I met Shawn, he told me he knew how to build a Tesla coil. We started out with normal looking Tesla coils, right? And
Yeah.
then Shawn goes, "Oh, by the way, Nathan, I have this idea, right?" And he comes
Mhm.
out with this Tesla coil that looks like an AC flyback. And I'm going, "Oh my God." And I thought, "Oh, well, that's pretty cool. It's still like a Tesla coil, right?" And he
Yeah.
pulls out this sphere and goes, "No, I got a better one, right?" And I'm like, "Dude, my
Yeah.
mind is blown. It's gone. There's no way. All right, you got
Thanks.
me."
That's
Uh,
awesome.
yeah,
That is
yeah,
so awesome. I appreciate that. Gerald was there too, I think.
yeah. Everybody was there,
Yeah, I
man.
appreciate that. Yeah, spheres seem to be the energy creators. I mean, I don't know if I want, I mean, I'll go cylinders because it's tried and true, but spheres, they surprise me all the time. And I
I th-
appreciate the encouragement.
I think you're just digging into it, Shawn. You're barely there. I think there's a lot more to understand about them.
I think you're right. I totally think you're right. Um, there's just, it's funny because when I was sharing with you guys, I'm learning things myself. Wait a minute, that lava rock is taking in all the energy. Wait a minute, it's bending the tendrils, the sparks. It's bending them, and then it goes nowhere. No heat. So that's in. If I can replicate that, I might be able to control the movement of these of these plasmas. If I could do that, I might be able to create an intense plasma field.
Well, okay, so I'll just tell you this. In all these projects that we do, it's the anomalies which make you famous. It's the anomalies that change everything in your whole experiment. It's not what everybody else did. It's the things that you can find that they didn't do or didn't see.
Yeah, exactly. Someone mentioned grounding my rocks. Good idea. I'll add that, grounding my rocks. So I'm jumping feet first into electrets, but I'm gonna keep my plasma experiments on the side, and hopefully I'll have some better, more interesting electret experiments. I mean, what did you think about the pizza in the oven? Yeah.
I think they're awesome, Shawn. I think the
you.
fact that you're experimenting and then you put it on there on that infrared camera to see exactly how long it takes, the fact that you're mapping that part out is interesting.
Yeah.
You know what I
Thank
mean?
you.
Because and then you can really see it. Yeah,
Yeah,
there's so much more there.
I
It,
appreciate that.
it takes a long time to get through all that.
Yeah, it's I just carry my phone with me, and if I'm not bedridden, I'll come out and just film my steps. And then I look at my 150 videos and just delete them. And that's what I do. I just present them as they come up, because that's been the easiest for my poor health, is I can't spend a whole lot of time on it, and I don't want to miss Wednesdays. So yeah, so I that's what I'm doing for now. I can't wait to really polish these and condense them a bit. And but these guys hang out a whole hour presentation. That's incredible.
You
That's
know what? I before you leave, Shawn, I just want to make sure that I tell everybody Inventor 3 is coming on tomorrow, and he has a bunch of Tesla coils. Okay, so you may want to check that one out, Shawn. He's isolating systems on it in order to pick up the frequency of the Tesla coil in different areas to pull energy out of them.
Wow.
So
he's on your channel tomorrow?
Yeah, he's coming on tomorrow. We're going to be live.
What time?
2:00.
2 p.m. California time.
Yeah, same thing we did here today.
Okay.
Shawn, he's got a cool one. He has a copper rod that runs right down in the ground.
Oh,
and
wow.
Two Tesla coils sitting right on top of it, right? And they're pulling energy right out of the ground.
That is so cool. I cannot wait to see it.
You're going to have to watch that, yeah.
I heard 8 Center was a great show last night, too.
8 Center was awesome. That was on Monday, yeah. And after this show, I'm going to meet up with him and Joe, and we're going to do some more. He's going to be on Monday for a while. And then we're also going to have, I'm sorry if I can't remember her name, but the lady that does all the Atlanta stuff, she's going to be on soon too.
Lulu?
And yeah, I think that's his name. I don't know. Lulu, I don't remember which one. I'm sorry for that, but I'll make Liz. 8 Center says Liz.
Okay.
So that's going to be amazing too. So we got those things coming up. And then I have another one on Friday. So I got another live. And I interviewed Nick. And he's got the DK Diker channel.
Okay.
And yeah, he did the Corona motor.
Wow.
And oh God, I can't remember the name of it. It starts with a K. Kapanzi, I think is the name of it. He did that coil. So
is he presenting Friday?
He's on Friday, yes.
Is this on the Free Energy Friday of Mike Faraday's channel? Or
no,
Friday?
It'll be on my channel for that one.
Okay.
So
wow.
We got a lineup coming up, Shawn. We got everybody. We asked everybody if they wanted to come on and present their channel or their invention or what they're working on.
Yeah.
And we've had a tremendous response from the whole community. And I'm gonna tell you right now, Shawn, I am the most blessed person on this planet I
It's
get to listen
awesome.
to every single one of them and understand every single experiment.
Yeah.
It's like a massive download of information.
It's your leadership, Nathan. I'm telling you, this is not easy to do. It's not easy to do to be faithful, creating your content. It's a thankless job. When you start YouTube, it is thankless. Lots of work, lots of critics, lots of blood and guts. And then you put in all that hard work until finally you've created a foundation of committed people that got your back, and then now it's flowering out. More and more people are coming, and when they see the format of our presentations, my format is laid back. It's my iPhone videos, and that encourages people. And I don't know the right words sometimes. I don't even know what I'm talking about half the time, but we're all learning, and I think that draws people in because people are afraid of criticism, especially in the fringe science. I think Ben said at one time he gets laughed at by everybody about his rodent coil, but yeah, you found your channel a safe place to share ideas.
Yep.
So yeah, and you just have so many smart people. I mean, I read the chat and go, oh my goodness, these guys are awesome.
That's mind blowing, isn't it?
Yeah, I just can't pronounce their names half the time. All right, well, it is that time for me. So I really appreciate you having me on the show, Nathan.
Hold on, Shawn.
And
Let's give you a round of applause, man. That was a heck of a presentation, Shawn. Thank you.
I appreciate that. Thank you so much. Thank you guys for listening and going through my lab with me and experimentation. Means a lot. Much love, guys, and God bless.
All right, guys. Thank you very much for showing up today, hanging out with us. I love the chat, guys. To all the new members out there, congratulations. I hope to see you in there. Got a lot of cool stuff. Previews of interviews if I've already done them. You get like a 2-minute segment before everybody else. Other than that, man, thank you, everybody. I really do appreciate it. Shawn, thank you for presenting today. Have a great night, everybody.
Much love, guys. I know that's cheesy.